Yeah.
Hello, my name is Maximilian Urias, and today I'm going to be talking about tangent lines and the applications of tangent lines. So first off, in a Euclidean plane geometry, a tangent line to a circle is a line that touches the circle exactly at one point, as seen right here, and never enters the interior. So if you look at this example, the tangent line is a straight line that that touches exactly one point on the line, which is around here, and never actually enters the interior. So now that you know that, I'm going to talk about the characteristics of tangent lines and the properties to further help us in applying it to different problems. So first off, the radius of a circle is actually perpendicular to this tangent line. So if we look at this radius, it is actually perpendicular or creating a 90-degree angle to the tangent line as seen right there. Second off, if we look at this example over here, the tangent lines that usually have the same length, or they always have the same length, as seen right here when these two tangent lines connect. An easy way to prove this is using side-side angle. So if we create two triangles, we know that both these side lengths are the same because it's the radius of the circle. We know that these two triangles have the same angle because the tangent, it's perpendicular to the tangent line as mentioned before, and then we know that they share the same second side in the middle. So by using side-side angle, we know that the third side, which is the tangent lines, are the same. Now that I talked about the characteristics of tangent lines, I'm going to go into actually using them in problems. So first, let's look at number 1, where it says angle A is circumscribed about circle D, and we're trying to find angle A. So first of all, angle A is circumscribed because when two tangent lines connect to each other outside the circle, it actually creates this circumscribed angle. So if we remember the characteristics, at this moment the tangent line creates a 90-degree angle, and over here also a 90-degree angle. So from this we know angle D, which is 89. So what we would do is, since this is a quadrilateral, it adds up to 360. All the angles add up to 360. So we know 3 of the angles, which is 89, 90, and 90, which and then plus A, which would equal 360. And if you calculate all that, angle A should equal 91. So that's an example of using what we learned. Now let's look at example 2, where it says find the major arc, which is this. This is the major arc of the circle. And we know that the circumscribed angle is 50, which is the opposite of the first. So a good step would be to find the minor arc first, which is this. We would do the exact same thing we did over there. We know 3 of the angles, so 90 plus 90. And if we add all this up, we should get we should get 130. So the minor arc equals 130. And then to find the major arc, it's a simple step. We just do, since it's a circle, we do 360 minus 130, which would equal 230. So the major arc would equal 230, and that's using tangent lines to find this major arc. Now if we look at the final one, it gives us that the radius of the circle is 6, and we're trying to find x right here. So we know that the radius is 6. So if we draw these lines, we know 6, 6, and we know that this line, which shares both triangles, is 8. So if we do simple Pythag to find this side, which is 8 squared plus 6 squared, which should equal 100, which equals 10. We know that both these sides equal 10. And to find x, we simply do x minus 7 equals 10. And then we find out x equals 17. So those are 3 ways to use tangent lines in order to solve problems. Thank you.